All right, one of the biggest parts of our unit on our trigonometry unit is converting to degrees to radians, and that's what I want to practice with first. But I want you to look at this picture. I really like the way they color code this picture. I like the way they describe what a radian is, because that's what students tend to forget or not know what it is a radian. You know what degrees are. There's 360 degrees in one whole circle. Seen that before. And you know what a 90-degree angle is, and you know what an acute angle, what obtuse angles are. But what about radians? So what I really like about this is the fact that it kind of shows you in this part of this picture right here that you've got a length of a radius in blue there. You've got another length of a radius in blue right there. And the third one is also a length of a radius. All three of those lines are the same exact length. So therefore, that is called 1 radian. 1 radian angle. So this angle right here, I could put 1 RAD up there if I wanted to. 1 radian. Okay, so that's a radian angle. That's the length of 1 radius. If you took your radius off the circle and laid it around the outside of the circle, wherever that 1 radius stops is 1 radian. Okay, now in this picture, it shows you that the yellow shows you that it's halfway around the circle. That gets you to what we call pi radians. We're going to see why in a second. And then the red one shows you that all the way around gets you 2 pi radians. Okay, so let's go to the back side of your trifold right now to start with, where it says notes. Okay, I want to look at that first today. I want to show you something. I want to show you, a formula that you've already used a lot. Okay, does that formula look familiar? What is that a formula for? Circumference of a circle. So that means like the walking around the outside of the circle. Like how far would I walk if I walked all the way around the circle? So this C is circumference, but it means 1 time around. 1 time around. And 1 time around, we could also say is 360 degrees. So our C, our circumference, is the same thing as 360 degrees. That's 1 rotation around a circle. That's what a circumference is. 2 pi I could also put as 6.28. How did I get that? 6.28. What's 2 times 3.14? 6.28, right? You're just going to take your 3.14, which is pi, multiply it by 2, you get the 6.28. So it's 6.28, and I'm going to change R to radians, because that's what a radius is. It's the length of a radian, 2 pi radians, because it's a radius length is the same thing as the radius that they give us in the circle. So 1 time around 360 degrees is the same thing as 2 pi radians. Okay, so 360 is the same thing as 2 pi radians. Well, they don't like to leave it without being reduced. Okay, because if you notice both sides, you have even numbers, you could divide them both by 2. So that means that 180 degrees is the same as pi radians. Now you could use both of those formulas. You could say 360 is 2 pi, or you could say 180 is pi. But it's better if you use the 180 as pi, it's more reduced. That's what they're looking for. So we went from the circumference formula to showing us how to convert from radians to degrees at the bottom there. 180 is pi. So go back up to the picture for a second. Take a look at it. Okay, do you notice that I had the 180 is pi on the yellow? Remember, I was telling you about that. So if I start right here and I go around half of the circle, basically I went 1 radian would be about here. Remember, you see the 1 radian right here? So 1 radian is about to there. A second radian is going to be about to here, right? A third radian is going to be about to here. So this is radian number 1, that's radian number 2, that's radian number 3. This halfway point is now another 0.14. Because what does pi actually equal as a decimal? 3.14. So it's 3 radians. Whoops. It's 3 radians right here. 1, 2, 3 radians plus 0.1 more to get you halfway around. So it's pi radians. It's 3.14 radians to get you the halfway point. It's 2 pi radians that get you all the way around because that's your circumference formula. 2 pi r is your whole circumference. 2 pi radians. So here's how you might remember it. So you're starting right here, and you're gonna decide you're gonna walk around. You're gonna walk all the way around the circle. So you start there, you walk halfway, and you get hungry. So you got to eat a pie. So you eat 1 pie. So you walk halfway around, you get hungry, you eat 1 pie. Then you start walking the rest of the way around, and then you get to the end, and you eat your second pie. So it takes 2 pies to get around the circle. 2 pies. 1 pie gets you halfway. 2 pies gets you all the way around. I just lost the feed there, so let's refresh that. All right, so let's take a look now at the trifold again that you have. Actually, no, let's look at these angles first. I want to show you some of these things. Okay, look at that picture. You've seen angles before, but what's cool is now we're going to throw in another angle. You know that if we start here, this is always our starting point. Always our starting point is the x-axis right here. Okay, if we're into this right there, we know it's acute because it's less than 90 degrees. Okay, but if we go past that, and we hit 90, we go past 90, now we're in the obtuse area. So we started here, you went all the way through here, it's obtuse, but once you pass 180, now it's called a reflex angle. Anything past 180 is a reflex angle. I could have 1,000 degrees. That's just going to be going around the circle 3.5 times or something like that. Okay, or more than 3 times. You just keep going around and around the circle. You can go as many times as you want to. Once you pass 180, you're in the reflex angles. Okay, that's what those are, reflex. So if you notice the difference between obtuse and reflex, if you're given an angle, one side is the obtuse, which is the side that's less than 180, still greater than 90 though, and then the other side would be a reflex. You could have an acute angle. Acute, this side would be acute here, and then this side would be your reflex. Okay, so the other angle would be a reflex angle. So you could have an acute and reflex as well, not just obtuse. Okay, just wanted to show you this real fast. All right, the last thing that I want to show you is the negative angles. There it is. Negative angles are going to go downward. Okay, so your negative angles, positive angles will go up counterclockwise, negative angles will go down counterclockwise. So this is negative 67 degrees right there. Negative 67. You could go negative 360 if you went all the way around, starting downward. Those are negative angles. Negatives go down, positives go up. Counterclockwise positive, clockwise negative. So that's important to note. You can have negative angles. Those are just parts of an angle, so you can see the arms of the angle. The vertex is always the part where the 2 arms come together, and then you've got your angle part of it. All right, let's go to the trifold. The main part of today is being able to convert from radians to degrees and degrees to radians. So we just saw that if you want to convert, or if you want to know what radians to degrees are, pi radians, 3.14 radians will give you half a circle, or 180. So 3.14 gives you 180. So if we want to go 2 radians, you want to multiply it by our conversion, but you want to put the radian number on top. If you're going 2 radians, you got to put that number on top. So you got to multiply it by the pi on top and the 180 on the bottom. We learned that pi radians is 180 degrees. Halfway around the circle is 1 pi. So pi radians is 180. So if I'm converting from 150 degrees to radians, then I need to take my 150 and I need to multiply it by the pi over 180 because I want to go 2 radians. Now, when they did this one, they actually reduced. I would have crossed out the zeros by dividing by 10, and then 15 and 18 can be divided by 3, and that gives me a 5 and a 6. And so that's how they got their 5 pi on top and their 6 on the bottom. So 5 pi over 6, just by cross-canceling. Okay, so let's try that and see if we can get that to work. In a minute. Let's do that in a second. Let's go to the bottom one first. We want to convert from radians 2 degrees. So if we want to go 2 degrees, we want our degree number on top. We want the 180 on top. So when they wanted to convert 3 pi over 5 to radians 2 degrees, they multiplied by the degree number on top. 2 degrees means you're going to put the degree number on top. So this time the pi's will cancel out. Most of the time, not always. If there's a pi in the radians, then you're going to cross out the pi when you convert it. And then 5 can actually go into 180 36 times. So when you multiply 3 times 36, that's how you get the 108. So you're either going to be multiplying by pi over 180 or by 180 over pi to convert from radians to degrees or degrees to radians, because that's what those are. That's what the conversion is. If you were to look at your backside, your last page, right there, you see it again. 360 is the same as 2 pi radians. So if I divide them both by 2, you're going to get 180 is going to be the same as pi radians. 180 is pi radians. Okay, so we're going to come back to that bottom part. Let's go to the middle now. Let's take some practice ones. How do we convert from degrees to radians? We want to go 40 degrees and we want to make it radians. So they actually set it up for us. We multiplied by the pi over 180. So I first crossed out my zeros because I divided by 10. And then I can divide both of those by 2, so I'm going to get a 2 and a 9. So your answer here would be 2 pi over 9 radians. 2 pi over 9 radians. 240, you want to again multiply it by pi over 180 because you want to go 2 radians. Since they both end in 0, I would cross out the zeros. 24 and 18 can be divided by 6. So you get a 4 and a 3. So 4 pi over 3 radians. Now look at the next one, negative 510. That's more than one time around the circle. Okay, you don't have to write this down. Don't write this, but I just want to show you. Here's where you would start. Negative 360 would get you to there. So you'd actually be going negative 510 is going to be somewhere in this area. So you would have gone this direction. You would have started here, gone downward, past the full circle, all the way to here where about negative 510 would be. Okay, so I just wanted to show you that. That's what it would look like. What we want to do is convert that to radians, converting it to radians. So we want to take the negative 510 and we want to multiply it by pi divided by 180, pi over 180. We want to go 2 radians. So radians has to be on top. Get rid of the zeros again because those are dividing by 10. 51 and 18, you can divide them both by 3. So you'd end up with a 17 and a 6. So negative, don't forget the negative, 17 pi over 6. Negative 17 pi over 6. And 675, 675 degrees. Almost 2 times around. 720 would be 2 rotations, so almost 2 times. We're going to multiply it by pi over 180. This one you cannot divide by 10 because 675 doesn't end in a 0, so you're going to have to divide that by 675. Let's divide it by 15. you'll get 45. Let's see. Okay, so 45. And then 180 divided by 15 is 12. You can still reduce that. You can divide those by 3. So 45 divided by 3 is 15. And 12 divided by 3 is 4. So your best answer would be 15 times pi over 4. Now, I was asked earlier today, can I make that a decimal now? Could I take my calculator and go 15 times pi equals, and then divide it by 4? Yeah, I could get 11.78. So this number I could say is 11.78 radians. No, don't write it down, but I could say that. It's that many radians. It's that many radius lengths. It would take 11 and almost 11 3/4 radius lengths to go 675 degrees. But what answer is better? Should I leave it as 15 pi over 4 radians, or should I leave it as 11.78 radians? What if it said find the exact answer? Exact. Does that mean change it to decimal, or does that mean leave it as a fraction? Leave it. Leave it as a fraction. These are more accurate answers. Leave them as fractions. I wouldn't change them to decimals unless it asks you to. Unless your answer is in decimals, or it's asking you to round it to the nearest tenth or something, then change it. Otherwise, simply leave it as a fraction. Last one is 390. So 390 degrees times pi over 180. I would first get rid of the zeros. It's easier to see the two numbers when they're smaller. So 39, I can divide by 3 and get 13. 18, I can divide by 3 and get 6. So 13 pi over 6 would be your answer there. So that's converting from degrees to radians. 2 radians means the radian number has to be on top. 6 through 10, you want to go 2 degrees, so the degree number's got to be on top. If you're going 2 degrees, then you've got to put the 180 on top. It has to be there. That's the number you're going to. What's nice about these, normally the pi's will cancel out. If the radian has a pi in it, it'll cancel it out. So you'll be able to just reduce now. Let's see, 180. Pretty sure 4 goes into 180. Let's check it out. 180 divided by 4 is 45 times. So put that as a 1, put that as a 45. So you just need 45 times 7, 315 degrees. So when I convert that, you'll get 315 degrees is the same as 7 pi over 4 radians. Negative 7 pi over 12, you're going to put negative 7 pi over 12 times the 180 on top and the pi on the bottom. If you're going 2 degrees, you need the 180 to be on top. So cross out the pi's. 12 actually goes into 180. I think 15 times. Yep, 15. So you need negative 7 times 15, which is 105 negative. Negative 105 degrees. Uh, 5 pi. What does 5 pi mean? If I told you, what does 5 pi look like on a circle? Think about it. It took me 1 pi to go halfway. It took me 2 pi's to go all the way around. How much is 5 pi's? 1 pi is half, 2 pi's is 1, 3 pi's would be 1.5, 4 pi's would be 2, so 5 pi's would be 2.5 rotations. So this 5 pi, just as a side note, you could put 2.5 rotations. Just as a little side note, you could throw that in there. But you want to convert it. So you're going to take 5 pi and you're going to multiply it by 180 over pi. You want to go 2 degrees. Your pi's will cancel, and all you'll have is 5 times 180, which is 900 degrees. So you can think about that. 2.5 rotations is the same as 900 degrees. 360 is one rotation, another 360 would be 720, and another 180 added to it would make 900. 900. Let's see, 4 pi over 9. You want to take that 4 pi over 9 and you want to multiply it by the 180 on top. You're going 2 degrees. Pi on the bottom. So cross out the pi's. 9 actually goes into 180 20 times. So 4 times 20 is simply 80 degrees. 80 is pretty close to 90. Think about a 90-degree angle. If it takes me 1 pi to go 180, how much does it take me to go 90? I need a whole pi to go 180. So what's 90 degrees then? Half a pi. So if I ate half a pi, then I would get me to 90 degrees. The other half a pi gets me to 180. Another whole pi, gets me all the way around to 2 pi's. So you can tell that this is pretty close to 1/2. 4/9 is close. 4/8 would be 1/2. So it's pretty close. It's a little smaller than 1/2, so it's a little smaller than 90. Let's look at the last one here. So you get 7 pi over 3 times, you're going to go 180 over pi. Sign the pi's will cancel. 3 actually goes into 180 60 times. 7 times 60 is 420 degrees. 420 degrees. All right, I'm going to let you go 1 through 8, but I want to do 9 and 10 on the next side because 9 and 10 are a little trickier. I want you to see them, and then you should have no problem with any of these. But if you notice, 1 through 8 are all just what we just did. And look at 80 degrees. Guess what we had down here for number 9? 80 degrees. So there's your radians right there, but still show the conversion, but it should be the answer to number 9. But I want to show you is 9 and 10 here. Because first off, 9 is a decimal. So if I was to convert that to radians, because it's in degrees right now, if I was to take 12 and a half, 12.5, and if I was to multiply it by, and I'm going 2 radians, so I got to put the radians on top and the degrees on the bottom, you would have a decimal inside of your fraction. You would have 1.25, no, 12.5, sorry. You'd have 12.5 pi over 180. Which you should not put a decimal inside of a fraction. That's not a good thing. So you want to move the decimals. You want to multiply top and bottom by 10. If you multiply it by 10, it moves that over 1, and it moves this over 1. It makes it 1,800. So you got 125 now over 1,800. That you can reduce. So if I took my calculator and I took 125, I know I can divide that by 25. So 125 divided by 25 is 5. So if I divide by 25, that's going to give me 5, and 1,800 I know I can divide by 25. It's going to give me 72. If I look at those two, I notice there is no other reducing. 5 does not go into 72. So my answer there is 5 pi on top and 72 on the bottom. That would be the radians. That's your most accurate answer. Don't make it a decimal unless they ask you to. And I really wanted to show you number 10 because it just says 2. What does that mean? 2 what? What is that telling me? 2 what? Degrees or 2 radians? If it's degrees, it would have a degree symbol. So what does that 2 have to be? It has to be radians. So are you going to put 360 degrees because you see 2 radians? No, 2 pi radians is 360. 6.28 radians. If I had 6.28 there, then I could say that's 360 degrees. That would be 2 pi radians. 2 radians just by itself is 2 radius lengths around the circle. So we just want to go 2 radius lengths. So you want to take your 2 and you want to multiply it by the 180 over pi. You want to go 2 degrees. Well, there is no pi to cancel out here. So if I was to multiply across, if I put a 1 under that, I would get 360 on top, and I would get pi on the bottom. Is that a good answer? 360 over pi degrees? No. Why do you not like to leave pi on the bottom? It's irrational. It's just like leaving a radical on the bottom. We're not supposed to do that. Not supposed to leave pi on the bottom. So you would actually want to divide that in your calculator, because the calculator will divide it, and it will give you a pretty accurate answer. So if you take your calculator, turn it sideways, or use your pi button, divide it by pi, you'll get about 114.59 degrees. So this is 114.59 degrees. That's what 2 radians would be. Just 2 radians, not 2 pi radians. 2 pi radians is all the way around the circle. That's 360. 2 radians on its own is the 114.95. All right, that should leave you a chance to do 1 through 8, but I want to look right at this very last piece here before I just let you go on this. So they want you to now focus on 1 radian. You just did 2 radians. What was 2 radians again on the last answer? 114.59. We want 1 radian. That'd be half of that. All right, you would just basically take the 114 and cut it in half. Okay, well, let's see what it would look like, though, if you're just focusing on 1 radian. You're taking 1 radian, and multiplying it by our conversion, which is 180 over pi. So you're still going to get 180 over pi. Because when you multiply anything by 1, it stays the same. You're not allowed to keep the pi on the bottom, so you're going to need to divide that. Using a calculator, you'll get 57.3 degrees. .3 degrees is 1 radian. It doesn't matter what shape or what size of circle you have. Humongous circle, tiny circle, 1 radian angle is going to be 57.3 degrees every time. This angle right in here is going to be 57.3 degrees. If this radius is the same as this radian, that's going to be a 57.3 degree angle. Okay, look at that last picture. It's a great picture. Again, it shows you how to break it up. It shows you how to break it up into radians. You've got 1 radian length that takes you here. You got 2 radians, 2 radius lengths. You got a 3rd radius length. Okay, so you could say that this is 57.3 degrees. This one's 57.3 degrees. This one's 57.3 degrees. You could subtract that from 180 to see what's left over, but I know that it's going to be 0.14 radians. I don't know how many degrees it is unless I subtract it from 180, but I know that halfway around is 3.14 radians to get halfway around. It takes 2 pi radians, or 6.28 radians, to get all the way around. So that is the back part there. Any questions on any of those so far? So take the time to do 1 through 8. I'll give you those answers at the end, and then you can work on the homework.